If we were to sketch representative functions that we can obtain by stretching the y equals x squared graph vertically, we would get a family of functions whose vertices are all at the origin, some opening upward, some opening downward, some vertically stretched by a factor more than 1, and hence looking somewhat narrower, stretched out this way, some flattened out by multiplying or by stretching by a factor less than 1, a positive factor less than 1, some upside down. Some of these are going to be fat, some are going to be skinny, but you can imagine that we would have a whole slew of shapes. And if we drew representatives of a wide variety of shapes, you can imagine what the graph would look like. That would be a graph of a function family generated by y equals x squared. There are other families generated by y equals x squared, as we will see. Now let's look at what happens if we stretch y equals x by a factor of 2. Well, what we get is every point moves twice as far from the x-axis. So we go from this far to this far, this far to this far, this far to this far, and this far to this far. The line remains straight. Since we've doubled all the coordinates, if we move over 1 unit, we'll go up 2 instead of going up 1. But the slope is going to still always be the same over this whole line. The slope will be 2 in this line instead of 1 on this line. So we've doubled the slope by doubling all the y coordinates. Could we take this graph and somehow match this graph? Well, clearly if we multiplied by the right number less than 1, maybe 1/3 or something, we could match the slope of this graph, but we'd still be going through the origin. If we then have a vertical shift function that allows us to move the function from here up to here, we could match this graph. It turns out that the main transformations we use are vertical stretches, vertical shifts where we just pick the whole graph up and move it without changing its shape or slope or orientation, and horizontal shifts where we can move it horizontally. And sometimes, especially with exponential functions, we also think in terms of horizontal stretches.